All right. Hey, everybody. And last night I presented at the Richmond AWS user group on OpenClaw. And I'm going to give you a quick summary of what I talked about because I forgot to do a recording. So without further ado, I'm going to share my screen. All right. Ready? Okay. First things first. This talk is about building personal assistants specifically on AWS with OpenClaw. Okay. And I'm Ford, and I'm a senior staff software engineer and tech evangelist at Geico. That's my boss there on the left, Paul Devitt, and then that's the mayor of Richmond on the right, who I've been working with for a Hack for RBA, which is my second title. And I joked at the meetup that I created the Hack for RBA organization just so I could give myself a cool title called Chief Hacker. Anyways, I'm a Richmond native and I'm a father of three. OpenClaw is the right tool for the right time. While the things like integration platforms, dependencies, even the intelligence of the models themselves, the demand for such a tool, and arguably even the tool calling itself with MCPs hasn't really changed over the past 6 to 8 months. The things that have really the dials that have moved a lot are the inference prices for not only the operations, meaning the cost of operating a system that relies on inference, but also the development cost. So using whatever the costs are for using models to create new tools. So what we saw in this case was Peter Steinberg, a pleasant man from Austria. He came along and was able to iterate and build out a tool called OpenClaw because the dev prices were low enough for inference, or that is running local code writing models to do things. And then also the operations inference is low enough. So now the tool that he actually built can be used and consumed by people because the prices are low enough to do things like, send emails, and create knowledge bases and do deep research tasks and whatever else we're going to talk about in a minute. So anyway, all prices across the board for LLMs have reduced, and that's the biggest thing that's changed. It's the right tool for the right time. This is a visualization of what I just mentioned. And we're kind of in the build window, right? So now we've finally got a tool that can be built and used. And because of these, prices have gone down significantly. OpenClaw is a persistent agent that talks via messaging apps. It's pretty simple. Input comes in through instructions via Telegram, Discord, WhatsApp, Signal, Slack, even iMessage. And it interacts with a gateway that then sends commands to an agent that then can interact with the terminal, like the shell, and issue shell commands. It can interact with the file system directly, and it can do whatever you give it API access to. So that includes emails, calendar, and all the things I just mentioned. So it's got full file system permission. So it's kind of an unhinged, wild tool because it can do so much and have such variable multi-channel input. From the process-based view, there's a lot going on, but this is kind of a simplified view. And there's a gateway, which is a node daemon that's running all the time. It has workers that do things, and they can also, at the time of inference, pull in skills, and also invoke browser and CLI subprocesses. You can see in the second diagram the process space as a square in the middle, and this is the larger ecosystem around the process space, which is the storage and state. It's the OS kernel services, and it's the network boundaries. And then finally, taking one more step back out, we're seeing the previous slide now in the middle, all abstracted, and then all of the things around the slide, around that central view. We've got the Telegram, WhatsApp, all the browser user interfaces, which honestly I don't like. They suck. I use SSM, which is through SSH, or SSM is just directly interacting with the host. And then you can do scheduled jobs, webhooks, and really any kind of external trigger. There's a lot of different ways you can do that. On the right side, similarly, there's a lot of ways you can configure outputs, and those are all listed here. And then my favorite diagram of all, this is kind of a wild one, but this kind of sums up what the thing does. Okay, so look at the top. We got WhatsApp, Telegram, Discord, Slack, Teams, iMessage, etc. That's the user surface. Messages come in and they come through a gateway. There's routing that happens. There's some queues and some concurrency controls, and there's a little bit of auth and permissions, but ultimately it's assumed to be a secure input, and then it ends up in the agent loop. The agent loop then has goes through an 8-step process, more or less, and then actually can and runs creates an invocation for the model, and that invocation it gets injected with roughly 6,000 tokens of prompts, and that is on the right, which is the memory core. Some of that's memory actually, so it's not all of it's memory. Some of it's a tools file that's going to list out some tools. There's an agents.md that's going to give it a base set of instructions for when it wakes up and needs to know what to do. There's a soul.md where you can give it personality, and there's a couple others that I'm not remembering, but they're on this slide. User.md is the one I'm forgetting. User.md declares who you are as the boss, so to speak. Okay. So if you were kind of zoned out on those last 2-3 diagrams, just look at this one right here. There are these 5 core files, and these influence how the system behaves. So when you make a deployment, all you're really doing is updating these files on the host, more or less. Every time OpenClaw wakes up on a heartbeat or via invocation, it looks for these 5 files and then decides what to do. This tool is kind of interesting because it unlocks, in my mind, 3 different problem statements that we didn't really problem spaces that we weren't really able to play in before. One of them is this like dynamic failure mode recovery. Okay, it can switch tools, recover from failure, and then develop an alternate strategy. This is in the act column on the left. Okay, and second, we have persist. So in this case, it can have an ongoing mechanism for ingesting new input. It can transform that input. It can schedule syntheses of that input and then send it out. And so what it is essentially is a persistence of intelligence across time. Lastly, the interact column on the right. This is a way for things, including other agents, to interact with each other. Now there's this whole new interaction layer where we can see agent-to-agent communication, which can essentially create emergent structures, which is very exciting and a little chaotic. Recently, since the fall, OpenClaw has risen to be the #1 starred repository in GitHub, surpassing even React in 100 days. And this is a photo from a province in China where I forget the name of the province and the city, where they are doing an OpenClaw adoption party, I think sponsored by Tencent or one of those big Chinese tech companies. And this is like 1,000 people that showed up to get OpenClaw installed on their machines. OpenClaw and AWS is an interesting question. I won't go through all these different options, but really Lightsail and EC2, stateful compute is the way to go. All the other models are serverless essentially, and we're not going to use them. So Lightsail and EC2 are the biggest ones, and because the biggest thing is we need stateful compute on here. We need something that runs all the time and wakes up to a heartbeat on its own accord, and that requires us to have, again, a stateful compute environment. Now, for me personally, when I think about this type of problem, I think about my own life and how I can maybe use it to connect different aspects of my own life. This is me across the board. These are the things that I'm doing every day, at least in a certain aspect. So, anyways, this is one thread that connects everything. So, how might I do this? I thought, okay, let me just break it up into structure. First, I'm going to get everything organized, and I want everything delivered via voice memos because I want to sit in my car and I want to dictate things that are on my mind. Okay. And I want to be able to also ask questions via voice dictation. So that was a voice dictation first, was one of my organizing structures. And I want to make sure everything that I give it gets properly, essentially filed away in a organized way. Okay. Not just dumped into a voice memo repository. Like I said, when I query it, I want it to be context aware. I want to know when I talk about one thing that thing is related to another thing. And lastly, I want it to be integrated so that when I do things like launch deep research tasks on certain topics, that context then stays with me. So, for example, when I need to go deep on a certain topic, like I'm curious about the AC unit that's running in my house and the model that it is, and what steps I can take to take care of it myself, and when I need to call the the AC repair person. And I want to have that so that when I ask it a question in the future, it remembers it and goes and queries that research set, which means it needs to be very structured. This is a view, and essentially what I ultimately settled on was I want to talk to Telegram, interact with the OpenClaw agent. It's going to pull in the 5 files, which is the context and everything it needs to know and what to do, and then it's going to talk. Basically, I'm going to interact with it in 3 different topics, and these topic 8, topic 2, topic 251 were essentially random numbers, so don't get hung up on those. But there's 3 topics. One is from my knowledge base, which is for Q&A about me and who I am and what I'm doing. Topic 2 is just dedicated to expressing deep research tasks because they're expensive, and I don't want the agent to get mixed up. I want to give it a special topic that it knows that every message it's going to get is going to launch a deep research task. And then lastly, I want a red telephone that I can use to update the system, because one cool thing about OpenClaw is you can tell it to update itself and fix its own bugs. The knowledge base kind of looks like this. Starts with the voice memo, goes through faster Whisper, or I think I'm using Whisper Large now, and V3, and it goes through raw layer, where it gets transcribed, ends up in a wiki, and goes through an LLM integration pass where it kind of takes it and puts it into a Obsidian format. And Obsidian is like a knowledge. Obsidian looks like this when it all gets rendered. This is my knowledge base right here. No, actually, you're not seeing that. I'll show you that screen in a minute. And I don't want to involve S3 at all, not yet, and I don't want any kind of async polling. And so this is the deep research flow, and this is the red telephone. Sorry, I went really fast through there. Deep research flow using parallel AI and using GitHub Actions to rebuild the index after new input has been added. Because everything's versioned in GitHub. I forgot to mention that too. I'm not putting it in S3. I'm putting everything in GitHub so I can look at it easily. And this is the red telephone. Because sometimes I want to fix things on the fly. Like I found a bug in the voice ingest, go ahead and update the model, run a version upgrade, and then test it. It can do all that with me asking. If there's a more complex feature request, I have a create GitHub issue.sh. They can take input and then create a GitHub issue out of it. And essentially, the create GitHub issue.sh could be replaced by just an instruction to use the GitHub CLI, but I digress. Okay, next thing, the live demo. So basically, I'm going to go into here. No, I need to change my screen here. Stop screen share. Boom. Okay, so this is BotFather. BotFather is a way to set up Telegram bots natively, which is really awesome. And that's just what it looked like when I got set up. And then this is what I ran last night during the meetup. I just said, hey, tell me about what hardware you're running on. Someone asked me specifically what CPU I was running and how much memory it had. So I looked it up real quick. It's not very much. And as you can see, it not only gave me the summary, but it kind of like gave me a little summary of the summary of the attributes of my hardware. But I can ask it questions like add. So that's the red telephone, so that I can talk with my system. But in this case, I want to add to my knowledge base and say add to my knowledge base. Actually, you know what? I'm going to do it from my phone right here so that you can see it in real time. Telegram. So I'm going to say add to my knowledge base that I sometimes record meetup demos from the Starbucks at Willow Lawn. So that just got added here, as you can see, and it's going to begin transcribing it almost immediately. Sometimes it's a little late to the jump. If you can see it up top here, now it's transcribing it, and it takes a minute, and I'll come back to it in a minute. But ultimately, that knowledge base ends up looking like this. And actually, this is a bad view. Hold on, let me fix the view here. Yeah, so it looks like this. And it's not going to show what I just added, update it yet because I need to sync it. But ultimately, like you can see, like for example, my faith is connected to my family, church I go to, friendships. I have product ideas. I have fitness that's connected to my career in some ways because I've maybe mentioned it. There's the trails I like to go on. But yeah, you can see how things are all connected in this. And this ultimately is going to prove like the way I'm going to be using this is I'm going to be able to interact with the Obsidian MCP to ask questions. And that's how it's going to kind of graph things out and give me an intelligent response. Anyways, skills. This is a huge part of how OpenClaw works. It uses skills. It needs a level of intelligence that's able to utilize skills. Skills allow you to access a deeper level of thinking and action for the same amount of tokens. I wish OpenClaw had better eventing. I'm going to go on. Ultimately, this is a super powerful tool. And if there's a problem, it's with me, honestly. My calendar is always out of date. My email is disorganized. I'm unable to communicate clearly with the people that I love. And I'm also often unable to like ask myself the right questions or ask people the right questions and explain situations. So that like level of communication is like a huge part of like if you are good at these things listed here, then you can use OpenClaw in a really powerful way to automate some parts of your life. But you got to be organized first. It's like kind of like garbage in, garbage out. So, like everyone says, with in the enterprise world, if you have a crappy data ecosystem, everything's going to be crappy on the other side. So, some bugs. One was a cache write tax that I was paying and didn't realize it. Every time OpenClaw turns on, it interacts with the AI brain, which is Bedrock, and it passes roughly 6,000 tokens to Bedrock. It's like almost 7,000 tokens, and so because the cache expires in 5 minutes and the heartbeat runs every 30 minutes, the cache is never used. So I was writing to a cache, to the tune of almost $200 a month, and ultimately only was reading $12 of cash. It should be flipped, right? And so, and it showed up as $0 on my Cost Explorer because I was using AWS credits, so I was shielded from actually paying the $200. But just beware, watch the cache. And then here was the fix. I just made the cache wake up once a day instead of once every 30 minutes. So the heartbeat is important if you're doing things like automating email responses, but I'm not doing that. All mine is like triggered by my own actions via Telegram. And so that's an important detail because this cost might be worth it if you're, for example, running a business and you need to be doing things every little bit. Like you need to be responding to emails quickly and taking action quickly. You may need actually a 30-minute heartbeat or even a 5-minute heartbeat. And so just beware, like that $200 might be worth it for you if you're running a business out of OpenClaw, which many people have done and are doing. But just beware. Another thing was model capabilities. So, like for example, when you turn the model on and ask it to look for tools and do things, if it's using Nova 2 Lite, which is AWS's recommendation, it's not going to find a lot of tools, and everything is going to fail, and it's going to tell you can't do things when it really can. And so that's just an important thing to know. I would recommend you use Sonnet 4.6 out of the box because it's going to be able to handle the right level of sophistication that OpenClaw needs. Okay, story time. So on Monday morning, I got started on this. I got banned from Telegram, or rather, my Telegram number was banned from the previous owner. I'd never used Telegram before, so I got it set up. It was banned, so I submitted a request and went on to WhatsApp. Okay, WhatsApp paired kind of, and I got WhatsApp working, but the pairing had to reset multiple times, and then it ran this like loop that caused me to get banned from WhatsApp. So then I was banned from WhatsApp and Telegram. I went to bed, rage quit, woke up in the morning, and essentially by the end of the day had Telegram reopened because they responded to my support request and opened up Telegram. All that to say, WhatsApp, the interaction, the way setting up WhatsApp is a little sketchy. You have to do like a QR code, but the bot father through Telegram is like it's made for bots, and so I would highly recommend Telegram. Telegram also supports topics, so you can break up threads and have one topic dedicated to one thing and not get your context confused. This is just about security, basically. Just beware. And here's the overall costs. I use it. It's about $40 a month for me because I don't use it very much. But if you're using it again for like a business, it's going to cost you like 200. and caching will help you there. And these are by the way, this is bedrock prompt caching I'm talking about this whole time. Um, I'm not getting into what's next. There's a couple things I want to tackle next. And this is how I built this whole thing. Did a bunch of research, set up a bunch of MCPs, got a sample repo, put it into a directory, and basically got Opus 4.7 to handle most of the details. And took me about 6 hours all together. I one way I kind of kept the thing stable was by creating a binding set of ADRs, architectural decision records that were unable to be changed, and so Opus 4.7 does a great job of honoring these ADRs. And when you ask it to make changes or it considers making changes, it will like basically say, "Hey, you're asking me to break an ADR, and I need approval from you, and then let's have a conversation about it." So it goes way slower. And I also use Superpowers, which is a plugin for Claude. And I used Cursor ID for the whole thing. Um, and every time there was something challenging that I didn't want to get to quite yet, I wrote it out as a GitHub issue, and I'll get back to it later. Otherwise, I got Opus to handle the little bugs as they came. And ultimately, I got an app, and then I wrote everything out. Every time I did something, I would pause and say, "Hey, Opus, write out what we just did in narrative format to like essentially a journal." And so by the end, I had this massive journal that documented everything that I did to get the whole thing started. Oh, whoopsies. And then lastly, when I went to build the presentation, I started with the journal. I started with the code base. I used Opus 4.7 again. And I said, hey, draft me out basically out of that journal, come up with a markdown draft of this deck. And I printed it out at home, sat there with my reading glasses and a highlighter and marked it up. Then I dictated it back on the changes that I wanted to make to it. And then lastly, I asked Opus, hey, given my updated version, what are some like ground truth everything? Like look for facts that could potentially be incorrect, and then do a search to figure out whether those facts are indeed correct, and give me the source for each one. So then I did that, and then I said, hey, I want to have a certain style of infographic that I want to use every time, and that style is like essentially a whiteboard, like the one you're looking at, with some orange in it. And then use that all the time whenever you make an image, and go ahead and make images for all the things, all the concepts I've described that don't fit into a slide. And it honestly, that I spent a lot of time on that. It didn't do a great job on that, so I had to kind of give it a lot of details and prompting. But ultimately, after that, I said, hey, give me a proposed style, lowercase, minimalist and white. And it generated the style you're looking at now, like this, like this style right here, with like the things at the top, the numbers at the bottom, all that stuff. And so then I got to create the whole deck. After that, that's it. We're gonna do an OpenClaw installation party next week, so you should come. And here are the QR codes. The middle one doesn't work, but I'll show you what that looks like in a minute. And by the way, this is let me show you real quick. Okay, so this is the repo right here that I want you guys to see. OpenClaw public at flying-pig-labs/OpenClaw public. And this is where you can download everything. It's got skills in there for you to get started. And it's got a doc for getting started. So just take your time, go through this. It makes some assumptions. And so you may have to get some things set up on the outside. But this is it goes through everything here. All right, that's it. Hope that was helpful. More next week.